this video, we move to the third part of this 0601 drawing geometry shape. And we will extend what we learned from the first and the second subchapter to make the animation for our the projectile's trajectory. So this trajectory we did in chapter 2 before. Now we try to make our animation like this illustration is you can see a ball gradually move through this projectile's trajectory at the trace. So that we will try to utilize the number 2 parts and make that as the base to change. So during this, I hope you can also feel what's the difference we are creating, like is the numbers of the arguments or the additional functions we need to create. So animating projectile trajectory. So let's see our purpose is to animate the trajectory of an object in projectile motion. So let's save this and make that bigger. So first is these two parts were library and modules the same, and because we need to calculate the trajectory, we need certain mathematical functions. So we import math like the, and then we have the one constants like g. So we just assume this as our same value like 9.8. So let's see the what's our primary parts is now we need two variables. The create animation function accepts the two arguments u and theta. This argument corresponding to the initial velocity. Velocity is u and the angle of projection. So now we have two. So one is u, another is theta. So and then we should define the theta. So we will try to get the inputs. So u is the float input. Enter the initial velocity in m per second. So that is the first, and then we ask theta. Theta is also a float number, but we also we later on need to convert the enter the angle of projection in degrees. And then we will make our catch is to prevent user have our the value error. So then we try and putting this inside try and see we have this except value error. If we go to value error, then we will print please enter valid input, and else we will call this else, and before we call theta needs to be converted to radians. So that this is the way we use the math function. If you want to see the original parts, I think is if you back to the chapter 2, so you can see here we have the trajectory, compare and draw trajectory. So we have some kind of those waves and gravity, and where is the quadra? So here is our trajectory. This function we did before. So now is we just try to use those as the base. So this is our min function, then we need to change our create animation. So this create animation, we have two variables to send them. And we need to define the interval. So interval is we will use that from the get interval. So interval, first we need to define. Also use the theta and u to get. So we will define the get interval parts. So f get intervals is u and theta. So this we have our calculation. So t is the total flight time. So if you see here is u times sine theta divided by g. So that is the total days flight time, and we have one is go to the maximum the height, and then we have the same time go to the this ground. So it's a double time. Then it's the 2 times u times sine. So we already we should have the mass sine. If you don't want the mass, you need to make the from mass import sine. But we just import mass, so let's have this complete and divided by g. So g is our global variable, so we can directly use that. And after we have that, is we need to construct our intervals list. So that is our empty list first, and start from 0 interval. Intervals is our list, and the interval in single is we have this unit. Then while star, just we divide this total time flight with those intervals. So interval is equal intervals dot append with start. So first is the 0, then we make is the start. We can use this plus equal interval. So either way is allowed. Then we start is we can print this the intervals. Then we can put all others are comment. So now here is the intervals. So we return intervals. Then this is the interval. And we print that and get intervals. Get intervals u theta. So let's make a run first. So let me give our sample data. U, let's make it 30, and the theta is 60 degrees. Then I didn't get any list, so print interval. So let's do this. So for interval in intervals, print interval. So let's see whether we have that. 40, 30. Yeah, nothing. So we don't have an interval. So let's star plus that. Star is put for I in intervals. Print interval while star, this one is so we give that, and the mass days as print t flight first. So to ensure it's more than 005. So let's see, 60, 30. So if I got these are minors. So that is the mass theta, and we got this transform is median mass radiance theta. Here. So I have some arrows. Here is the theta. So let's make it 60 and 30. Good. So interval. So it's quite large, but every part is our interval. So let's just print intervals. Run 60, 40. Yeah, let's see. So we have this time, and then we got this is 788, and then t flight time is this one. Then we go to this t flight time. So we keep adding 3, but it's only give this short. So let's make our smaller. So maybe just 10 and with 20 degree. Now I got is 0.695. Let's see. So what is 0.698? So then when they add another 0.005, it's overflow. So that looks like we got the enough, the correct for our interval first. Then we have a list of time, and then we use this interval. We can update our the position. We don't need this the draw this circle. So that is we just use this center circle is inside this one. So t is intervals. So let's see the update the position. Update position is we have this I and we have our the circle. So let's see where is our circle. We don't draw this circle from here, but we will have our circle first here. Then we add patch circle and update position is here. So first we already defined the circle. So we have this circle part and we define some more the arguments. So intervals. U, definitely we should transfer U theta. So ensure so you don't have this typo error like me. And then let's do this one by one. So first we have the T. T is our intervals. And we give that as I because I is the self-changing those based on the frame. So then T is based on the I, then we can have the different this interval. Then X and Y is based on our earlier, I think so we have those X and Y, we have this formula. So we still use this U cosine theta times T is X, U sine theta times T minus half GT square. So that is still keep usable. So we just because we have our I is changing, so we don't need to use our this looping. So the T is already automatically changed the variable. So we just use the cosine theta then times T. T is having the I inside. And Y we put is the U times the mass sine theta times T and minus 0.5 times G times T times T. Now we have the position. So what we want to do is we need to update the position. So circle dot center is equal to x and y. So we just put this because the center is our tuple. So we just update this tuple with another two pair data. So then we return circle. So here I suppose that we don't need this comma. So let's keep that. So and the create circle, we put that inside here. So we don't need this separate create circle function. So then let's go to our primary this create animation. So we should have the xmin and we define this limit before. So actually, so we can have this as well. So let's make we also have this PCT, so figure, so GCT, so this one is okay. And then we have this Excel is defined by xmin, xmax. So you can put that inside here, or you can calculate that before. So that is more easier to be reviewed if we like this way. So xmin is 0, xmax is u times mass dot cosine theta, just see the highest height times the interval. That is the max. So just the last the time interval. So -1 is the last one. So that's the most right. And the y min is 0. And what is the y max is here. So we should have the t max first. So let's put that before. So t max, just the t max, don't need the underscore. So u times mass dot sine theta divided by g. So you can feel is when we try to learn more and more on mass is you need to try to link back with your mass theory as much as possible. So that will help you to understand the logic of Python's programs. U mass sine theta times t max minus 0.5 times g times t max, then times another t max. That is like the square. So now we have this min and max. Then let's put this ax. So we replace this. Is the x min to x max, and here is the y min to y max. Then what we can do is we can make our the circle then. So circle is here. We are not having this create circle or parts. We just directly use this PLT circle. Then we save another code. So this circle is the center is the x min and the y min. So yeah, the capital circle from the most the starting point is x min, y min. So and then we put this are very small the radius, and then we will add. So this is still right. And if we don't have anything here, we only have one static ball, I think. So enter here maybe 6, 30. Yeah, we got this, and we haven't showed that. So let me see. So 60, 30. So actually, our small ball is starting from here, but it's not showing easy. So let's make that 10 times bigger. So 60, 40. So now you see here. So it's our big ball now. So but we will not have that so big. So just 1. And then as a continue, we already come to here. And then let's make this back. So our animation. So we will call animation function animation. So figure we will transfer, and now we will have the update position function to replace this one. And then these figure arguments we will transfer 4. So we don't need to transfer this I. So first is the circle. Then interval is we transfer intervals, and transfer u, transfer theta. And the frame is we will use the variable. So we will put that is the length of intervals. So interval, remember, is a list. So length is the how many element or how many timestamps. And the interval here, the 50 is one. That let's keep that 50 and don't make that repeat. Just go. Oh, let's make that repeat. Is fine. So if they go to the last, then they go from back. And then we can give a title, projectile motion demo, and we give also the X label, it's X, Y label. So those are things we learned already. So now let's starting to see here. If I go to this 60 velocity and is maybe 50. Now you can see our ball is starting to do. So 50 is quite slow. So let's make that a little faster. So maybe 5. 1 is too fast to me. So let's say it's 70, 45. Yeah, now you can see this one. So I think it's we don't have our color, so it's just our this blue default color. So it's come to the maximum. So you can see here, then it's starting to drop because it's our this area is we put that is they will occupy all the X and Y. So that is the based on the X and Y maximum. So here it coming to here, then they come to this again. So it's too much. I think it's our ball is quite small. So let's put this. Maybe I make that bigger and make this of 2. So let's go to here. Demo again. So maybe I go to 7 and 6, 60. Now this one is getting the faster, and the ball is getting bigger. So, but it's depending on our velocity. So let's see. So I put velocity is faster. So 100 and 50. So you should see that its velocity is getting faster because it's you see this x axle and y axle, the number is getting bigger. So then this it have the too long, much longer distance to travel. So you don't see that it looks like it's getting very fast. But if I put it smaller, so like this, I just have 10 and have the 45. Now you can see our ball is quite big now. It's like a huge sun. So that is depending on is how you adjust your velocity and the theta, the starting these angles, the initial angle. So I hope this video is gave you some idea is how you can to manage this function animation object, we try some the different way to configure the transfer the arguments, but primarily it's the same to the last one. But whenever you put some the argument go to the variable, then this you can manage your animation in more interactive way. So I hope is you also make this the same the successful result. In the next video is we will move to the second chapter, sub-chapter to draw the fractal. So and that is a kind of the complexity of these drawings, making from the simple the base shape, and we will try to learn some more the libraries and the functions from them. Okay, so thank you for your interest and watching this video. See you in the next one. Bye for now.